Smart Child Zone presents Newton's Laws of Motion. It states that the rate of change of momentum of a body is directly proportional to the applied force. Newton's second law of motion deals with situations when a net force is acting on a body. It states that, when a net force acts on a body, it produces an acceleration in the body in the direction of the net force. The magnitude of this acceleration is directly proportional to the net force acting on the body and inversely proportional to its mass. If you think of acceleration as movement, then, the greater the mass of the object, the more force needed to make it accelerate. Objects with a greater mass have more inertia. It takes more force to change their motion. A 400 kg rock is a lot harder to move than a 40 kg rock. It will take twice the amount of force to accelerate the wagon with 20 kg, as the wagon with 10 kg. But in order to make an object accelerate or move, you have to apply a force. Because the mass of each ball is different, each ball will travel a different distance and at a different speed when it is hit with the same force. Twice as much force produces twice as much acceleration. Twice the force on twice the mass gives the same acceleration. How much an object accelerates depends on the mass of the object, and how much force is applied to it. The effect of a 10 Newton force on a golf ball would be much greater than that same force acting on a truck. Newton's second law formula is given as force equals mass times acceleration. – 20 Newton force moves a body with an acceleration of 2 meters per second squared. What is its mass? How much force is needed to prevent a body of mass 10 kilograms from falling? If there is a block of mass 2 kilograms, and a force of 20 Newton is acting on it in the positive x direction, and a force of 30 Newton in the negative x direction, then what would be its acceleration? The negative acceleration indicates that the block is slowing and its acceleration vector is moving in an opposite direction directed opposite to the direction of motion. How much horizontal net force is required to accelerate a 1000 kilograms car at 4 meters per second squared? Newton's second law relates an object's mass, the net force on it, and its acceleration. Therefore, we can find the force as follows. Therefore, the horizontal net force is required to accelerate a 1000 kg car at 4 meters per second squared is 4000 Newton. Two masses are hung and connected to by a light cord and hung from a frictionless pulley of negligible mass as shown. Mass, m1 equals 3.00 kilograms, and mass, m2 equals 2.00 kilograms. When the two masses are released from rest, what is the resulting acceleration of their masses? Given in the picture, a horse is pulling the horsebox having 8 kilograms mass in it, with a force of 40 Newton. If the applied force has an angle of 37 degrees to the horizontal, calculate the acceleration of the horsebox. First, we should find the x and y component of force. Since the motion is in x direction, we take the x component of the force. The horsebox is traveling with 4 meters per second squared acceleration. Find the acceleration of the block given in the picture below. How much horizontal net force is required to accelerate a 1000 kg car at 2 meters per second squared? A motor car is moving at a velocity of 108 km per hour. It takes 4 seconds to stop after the brake are applied. Calculate the force exerted by the brakes on the motor car if the mass along with the passengers is 1000 kilograms. First, we convert initial velocity from kilometer per hour to meter per seconds. Now we need to find the force exerted on the brakes using this formula that contain initial and final velocity. The negative sign of the force means that the force was exerted in the opposite direction of motion. A block is pushed along a horizontal frictionless surface, with a horizontal force that varies as a function of time. As shown in the graph here. At time equals 3 seconds, the acceleration of the block is 5.0 meters per second squared. Find the mass of the block. As you can see from these examples, the larger the mass of an object, the more force required to get it to move at a certain speed. For example, in football, when a quarterback throws a football, they are applying a certain amount of force to it. As they do this, the football accelerates as a direct response to that force. If a quarterback throws an object with a larger mass, such as a rock, they will need to apply a much greater amount of force in order to get it to have the same amount of acceleration. For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.